Good morning, Math 1. It's a great day. Glad you're here. It's an exciting week. We could get some snow, which is always fun. Fortunately, we live in a place where snow is typically fun. It's not scary snow. We've been dealing with arithmetic, we've been dealing with sequences in particular. And there's two kinds of sequences we've talked about. Geometric, and geometric sequences are those ones that have generators that involve repeated multiplication, either by a number greater than 1 or a number between 0 and 1. So multiplication is the generator. And we've also talked about arithmetic sequences, and we're going to spend the day kind of reviewing arithmetic sequences and seeing how it relates to other things we've dealt with this school year. So as we go through this, maybe circle back and think about these questions. What type of sequence is this? So if you're presented a sequence, what is it? How do you know it's that kind of sequence? How can we write the equation for that sequence? And is there another way to see it? Can we flip it to one of our different multiple representations? So we've said before that a sequence is just an ordered list of numbers. The order in which the numbers appear in the sequence or list of numbers matters. Sequences have their own notation and vocabulary, and it helps describe them, such as term and term number. Question 57 is going to help us use this vocabulary and this notation. So I would like for you to write now in your notebooks, go ahead and write down that this is problem 57, and I want you to copy this sequence. So we're writing down -9, -5, -1, 3, and 7, and it continues. So this is the sequence we're going to be thinking at as we complete this sequence. So the first question is this sequence arithmetic? So an arithmetic sequence is one that is generated by using repeated addition of either positive or negative numbers. And as I look at this sequence, right, my eyes are drawn to this because I can do the arithmetic fairly easily. If I take 3 and I add 4, I get 7. Or I could say it another way, 7 minus 3 is 4. And in fact, if I take -1 and I add 4, I get 3. -5 and 4 is -1. -9 and -5 is 1. So I have here, like, yes, this is arithmetic, right? How do I know? This is arithmetic because it involves repeated addition. We keep adding the same value again and again. Let's go down to question B. Still same sequence. It says, what is the first term of this sequence? So the first term of this sequence is the number -9. So I'm going to write -9 is the first term. So if you're presented with a sequence, you can tell me what the first term is. And you should be able to identify if it's arithmetic or geometric. The next question is, when the sequence generator adds a number to each term, the value that is added is known as the common difference. It is the difference between each term and the term before it. Okay, so it's the difference between each term and the term before it. Let's think about that. It's the difference between each term, so I could say this term, and the term that came right before it, right? So if I look at that, I can say, oh, each term, in this case 7, and the term before it. Let me look at another one. It's the difference between each term, there's a term, and the term that came before it, the term before it. So for this I can say, oh, that's -5 minus -9. Well, 7 minus 3 is 4, and -5 minus -9 is -5 plus 9, which is also +4. So this question says, what is the sequence generator? So the common, I'm going to say two things, right? So I'm going to say my common difference is for the generator is add 4. So a generator, remember, is both an operation and a value. So we continue to add 4 to generate this sequence. So that's ABC. More. Next it says D. Record the sequence in a table. Remember, a sequence table compares the term number n to the value of each term t of n. Okay, so let's go ahead and write a table down for this sequence. So this is going to be A, B, C, D. So for this sequence, we have a space for the term number, and we have a space for the value of the sequence at that number. And a sequence is always going to start with 1, right? The first term, the second term, the third term, the fourth term, the fifth term. So these are the term numbers, and it's just the order in which the values appear in the sequence. And the values at each of those spots are just the numbers in the sequence. So the first term is -9, then we go to -5, -1, 3, and the fifth term is 7. Nice. The next thing that we're going to do is we're going to graph this table of values. And you do not need to use a piece of graph paper. You can use your composition notebook. But a couple minimalist lines we should see. We should see an x-axis. So I'm drawing this. And we should see a y-axis. So draw these two things in your notebook. And you can see that I'm going from -10 up to +10. And I've got 1, 2, 3, 4, 5. So at 1, right, when x is the number 1, we're living here at the number -9. 1, 2, 3, 4, 5, 6, 7, 8. So each of these lines going down are 2. So 9 would be right here. At 2, we are at the number -5. So that's 1, 2, 3, 4, right in between 5. At 3, we're sitting at -1, which is in between these two. At 4, we're sitting at 1, 2, 3, which is here. And finally, at 5, we're sitting at the number 7. 1, 2, 3, 4, 5, 6, 7's right here. So when I look at this arithmetic sequence, I can see, based on the graph that I've produced, that this is linear. In fact, let me grab the ruler, and if I connect these dots, I can see, yeah, this is very much a linear relationship. And the other thing that I notice is my generator was +4, and in this I can see if I'm sitting here, I go up. Each one of these is 2 lines, so this is 1, 2, 3, 4. So I went up 4 and then over 1. I went up 1, 2, 3, 4 and over 1. I went up 1, 2, 3 and 4 and over 1. So I can see that my slope is the generator value. In other words, the value is 4, right? And we are adding +4. So that slope has a particularly important role in this sequence. And we've seen this before, right? We've seen this before. In fact, if I take this and I go back 1 unit, I'm here, and I can go down 1, 2, 3, 4. So if I go down 4, and I was at negative 9, and I go down 4, I'm going to be at the number negative 13. And in fact, if I want to, and we're asked to do this in the textbook, we can write an equation for this sequence. We're going to start the equation like this. T of n, which means what? The value of the sequence at the point n. The value at the sequence at point n is equal to 4 times the value of n, and then minus 13. So it turns out the generator is the slope, right? And we see this reflected here. Here's our slope. And the value of our y-intercepts, right, where we're crossing the y-axis, and you see we're crossing the y-axis at this location, right here at 13. This is that value. It's the value of our y-intercept. Now, if I was to take any one of these n values, right, if I take any single n value, for example, if I take when n is 1, and I plug it into that equation, this would become 4, right? If I plug in the number, for n, this would become 4 minus 13, which equals negative 9. If I was to plug 2 in there, it would become 8, right? When 2 goes in is into the function, 4 times 2 is 8, and 8 minus 5 is 13. So this is our old friend, a linear relationship masquerading as something we call a sequence. So there are many things that we can do in this section, but we're going to finish with this question today. Trixie, a student in someone else's Math 1 class, wants to create an especially tricky arithmetic sequence. She wants the fifth term of the sequence to be 11. Now, a great way for me to organize this is I might think about an ordered value where I've got the term number and then the value of the sequence at that spot. And I know I always start with the first term, second, dot, 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 dot. She wants the fifth term in the sequence to be the number 11. And furthermore, if she goes way down, she wants the 50th term, way down here at 50, to be the number 371. So the question is it possible to determine the common difference, the sequence generator, and the initial value 0, and then write the equation for this sequence? If it's not possible, explain why not. Well, I could be wrong, but I believe this is possible. And what we're going to do is we're going to consider our old friend, the slope. And if you remember, slope is equal to the change in the y values, right? Which is in this case, it would be our outputs. The change in outputs divided by the change in the x values, which is the change in the inputs. So if I look at this, here's my output values. I'm going from 11 to 371. So if I want to show the change, in the output, or I'll just say the change in y, the change in the outputs, it's going to be 371 minus the number 11. And the change in my inputs is going to be 50 minus the number 5. And yes, I'm not ashamed to admit it, I'm grabbing a calculator. 371 minus 11 is 360. So my numerator is 360, and the denominator is going to be 45. That's 50 minus 5. So this slope, if I reduce this, I think it reduces divided by 45, is the number 8. This is the number 8. So that means I know what the generator is. The generator is add 8. Well, if I know that that's the generator, we know that the initial value, t of n, is the y-intercept of this sequence. So if I could come back in and I could add the 0th term, if I could go back and I could get this number, I would have everything that I need to write down the equation, the sequence. Well, I've got the slope, I've got the y-intercept, and I've also got 2 points. I can do this a couple ways. Here's room for the third term, and here's room for the fourth term. I could take the number 11, and instead of adding 8 to go forward, I can take 11 and I could subtract 8. When I do that, 11 minus 8 gives me the number 3. So the fourth term would have to be 3. And if I keep doing this, right, every single time I go backwards, I want to subtract 8. The next value I get is negative 5. And then that means that the second term would have to be negative 13. And the first term would have to be negative 21. And if I went back one more, the 0th term, which is not part of the sequence, but it's important for the equation, is negative 29. So the sequence itself looks like this. It's the numbers negative 21, comma, negative 13, comma, negative 5, comma, 3, and then it continues like that. But now that I know the 0th term and I know the generator is plus 8, I can use both the 0th term and the generator to write down the sequence. This sequence is t of n is equal to 8 times n minus the number 29. And just as a quick check, I'm going to take this number and I'm going to put negative 21 in here. Let me grab an on-screen calculator. So my goal here is just to put the number negative 21 in for the first term, and or I'm sorry, put in 1 for n and see that I really get negative 29. And yeah, if I put in 8 times 1 and then I go minus 29, I get negative 28. Right? So I can see that when n is equal to 1, this sequence gives me negative 21. Let's do another value. Let's put in, this is the first, second. If I put in 3, if I want the third term, when I put 3 into this equation, it should give me negative 5. So on the calculator, I would just go 8 times 3 minus 29 equals, and yeah, it gives me 20. So this is the sequence. And if you think about what we did, we just found the equation of this sequence by figuring out what the slope was, which was our generator, what we keep adding, and figuring out what our y-intercept was. So that's it today, just those 2 problems I want you to have in your notes, and you know what your assignment is for this evening, and I'll list it in Classroom as well.